City of Philadelphia has some open data available. So out on their GitHub, James Tyke was able to identify a good data set which would fit this demo, which is Philly Energy. So what we have here is we have different buildings and different types, and they're rolled up into categories. It then also has how much energy they're using on the end here. So we can analyze different types of buildings and how much energy they use. James was able to write a quick Ruby script to convert this into Elasticsearch's indexing format. So this is using the bulk API for loading. So in bulk, when you submit a bulk, everything is line delimited. So my first line, scroll to the top here, my first line, it has the name of the index that will be indexed into. It has the type, and you can also provide an ID here. I don't provide an ID. Elasticsearch will automatically assign an ID if I don't provide one. And then we have here the data itself is the second line. All right. All right. So back to the schema. So most of the data in here is either double or long. So I found that. Oops. So there's many data types available in Elasticsearch. So you have double, long, string, date. I believe there's a couple others too. But those are the ones that I've used so far. So, but down here towards the bottom, where's my key? Yeah. I want to highlight this one. So here, remember that key analyzer I defined at the top? So here's how you define this as a key. So the property type I wanted to treat as a single string and did not want to break that apart on spaces or other delimiters. So I declared it as a string and analyzed as a key. Also important for aggregations is many of the aggregators require either a double, a long, or a date. There have to be some sort of numeric value that can be summed when you're doing aggregations. So I declared anything I want to aggregate on as such. So I'm going to take the data. So the first thing I'm going to do is let's create the schema. So I'm just going to drop it in here, hit curl, and enter. And now if I jump back to the head tool, we'll have a little bit more information. So now I have a Philly Energy schema. I have 0 documents. And I have the couple bytes it takes for the metadata. And here is my schema. Exactly what you saw, plus a couple of pieces added. So we have the replicas defaults to 1. I could have overrode that. We have the version and the UID were added. I think everything else is exactly what I specified. Oh, and the aliases. So I'm going to also add an alias. So if I jump back. So I do a put command, Philly Energy. That's going to be, let me turn back to Notepad so you guys can see. So I do a put to Philly Energy underscore alias and then PE for Philly Energy. I don't like to type, so I usually use short aliases for most of my indexes. And if we jump back to the head tool, you now see that we have an alias PE. You can also see that we have our 5 shards. These unassigned are the replicas, because it did a default of 1 replica. They're unassigned right now because it's all sitting on my single box. Usually you would turn those off. Also, up here, we have cluster health yellow because at this point, if one node of my cluster fails, the data will be lost because I have no replicas. So the next thing I'd like to do is load some data. So to do a bulk load, I have curl-s host to localhost _ bulk. This will then do a bulk load of that file that I just showed. The data --data binary, and I just put it in temp pe.dat. So run that. Jump back here, refresh, and I have 259 documents. I can browse those documents now, and we can see a little bit more about what was added. So we have our document ID at the top, we have our document itself, and then here you can see we have the electrical use, and we have the property type is fire station for this individual document. Any questions? All right. At this point, I'm going to jump into a few queries. So we can use a structured query, which gives you a query builder interface. But for this example, I'm going to use any request. So I'll grab the queries out of here. All right, so the first thing I want to go over is the query. All right, so I'm doing a match all query, which is going to bring back all the documents. I'm then declaring a facet that will group my query together based on, in this case, a term. So each of these is a term. I said that don't split it on spaces or dashes, so the whole thing becomes a term. And then it's sorted by number of hits. This is the format that you would submit to Elasticsearch 090 or below for a faceted query. We have our field, which is property type, and we have our size is 0, which means I won't get any documents back at the top. Facets are very useful for storefront where you want to display different categories of products and the count that match each of your searches. So that's one use case for a facet. All right, you can also do a script in a facet. I think I'll skip the script and go to the new aggregation style for faceting. So using aggregations, it becomes very similar. I still do my match all at the top, but then I say aggs to say I'm doing aggregation. I name my aggregation, and then I again use terms and the property type, and I get the count of documents by type. Exactly the same results, just I get aggregations and by type, and then I did a bucket aggregation. So this is very similar to the features of the prior versions of Elasticsearch, but this is in the new format. Where this gets more powerful is when you go into, let's say, a histogram. Let me just put it on the screen and then go over it. All right, can everybody see that? All right. All right. Slide that over a little bit. All right, is that big enough for everybody? All right, awesome. All right, so at the top, again, I have aggregations. I did by year with my name, and I said it's a histogram. Now what I'm doing here is I'm saying the year built interval of 50. Inside of that aggregation, I'm then doing another aggregation, which is the property type. So this is telling me how many of each property was built in 50-year intervals. So as we go through this, we can see in 1700, there was one building built recreational. If I jump to the bottom where you get a lot more documents, you can see since the year 2000, there have been 2 recreational, 2 police stations, 1 library, and 1 prison built. So you can nest your aggregations together. You can continue nesting them. I'm not aware of a limit on the depth, but I've only done nested of 3. So this shows just one way you can do it, but I still haven't added anything together yet. So this is another dimension on top of faceting. Any questions before I move on to other aggregations? Right. Next thing I wanted to get into was average floor space. So what I have here is I have a term aggregation with property type asking for size 50 so that there's less than 50 types. I'm ordering descending on area. Area is my sub-aggregation. So I have aggregation area down here. Area is an average aggregation. This will take the average per property type for building area. So with that, I can say that on average, an office takes up the most square feet per building. And then second is a courthouse, and then a prison. So I'm able to analyze on average and break it down by different types. Any questions on that before we move on? All right. So then here's where we start to get into some analytics. So let me make this a little bigger. Can't see the last 1 there, but this is a 1, even though you can't see it. All right. So now I take the same part of the top here, query, term on property type. But now I'm going to say do descending by electricity by area. So what I can do now is I'm going to do average, but I'm going to put a script in here. What I'm going to say is take the electrical use divided by the area and return that, and then take the average per building. So what that gives me is it's saying that, first I have to run it. This usually helps. So what it's saying is there's 595 units of electricity for office space, and that's the top, and then there's 425 for a courthouse, etc., and that's the electric use. So I can break down the electric use per square foot by building type. And now I know what my most inefficient building is. To put a little bit of light behind that, let me throw another one up here. So what I added to this one is at the bottom, I wanted to know what's my overall average. So I dropped this one in here outside of this aggregation and next to this one so that I could just see the overall average electricity use across all my buildings. So the overall is 50,000, whereas when we go back to the I'm trying to grab that corner. Alright, sorry it's in the middle, but it's 595,000 compared to only 50,000 as your overall average, which shows that this is a much higher outlier. If we scroll to the bottom, we can see that the fire station uses the least amount of electricity at 83. So we can see there's a wide variance in the electricity use because we have 50,000 average, 83 for 8,000 for fire. Yeah, 8,300 for a fire company. So it varies very widely. We can also gather more statistics than just average. There's yeah, go ahead, Jonathan.
You finish it.
Okay, I was just going to say you can also gather more statistics. You can get sum. You can get a stats, which just gives you all the statistics broken down in a single query instead of doing each one individually. So there's many other different aggregations you can do, and there's many more in 1.1 that I haven't got a chance to check out yet. I know cardinality was just introduced, percentiles was just introduced, so there's many new features that I just haven't got a chance to play around with yet. It was just released. Go ahead.
Yeah, so is the aggregation happening at the shard level and getting rolled up, or like is it all getting rolled up on top and then aggregating?
I'm not sure. I haven't looked under the covers at all. Do you want to? Can you come up to the mic?
Sure. So how this works is when at the beginning when the index was created, there were 5 shards, right? Was it 5?
Yeah, 5 shards.
Yeah. So the basic overview is when you execute this query right here, it distributes it in parallel to those 5 shards, and then it takes back the result and then it collects and merges all the results back, and then whenever it comes back over here is the merged result from all of those shards.
Yeah. So,
okay. So
say
if
I had each shard on one separate box, right?
Sure.
Like, which would have been the ideal case. Unfortunately, we're running it on one box. So processing-wise, does it happen like at a shard level and then it gets rolled up?
That's correct. Yes,
Okay.
it's in parallel. So
Okay.
it executes in parallel, and then it gets pulled back, and the node that this query gets sent to, and then it gets merged up there, and then finally it gets returned.
Awesome.
So we get unique result on each shard when they distribute the search result?
So the question is, so you get a unique result on each shard.
So
We
my
distribute
question is can the same document be present in 2 shards?
No, so when you index a document, like for example, how many documents did you index?
I
293 or something.
think it was 259.
Okay, 259 documents, right? So let's say the first document, it goes into one of those 5 shards. The second document will go into one of those 5 shards. The third will go into one of those 5 shards. So each document will only live in one of those shards.
Yeah, I
So
don't think
overall, the performance of this, if we've got, say, millions of documents, it's going to be favourable, really, really good. What kind of response time do you get?
The answer
In
to
the
that,
aggregation framework?
it depends. But I think I cannot give a straight answer simply because there's many different factors that affect that. But the thing that's important to you guys is you know that you can cut your data up, and then you know that you can distribute the data out to as many nodes as you want. So in other words, you can make it perform however you want, as long as you have money and hardware.
So here, if I do just an average of electric use on all the documents, and then it spreads it out, does the average on all the nodes, and there is still one level of computation yet to be done by this node because it has to again find the average of
That's
the
correct.
averages.
Yeah. So there's a merge process that happens.
Okay, so that's
Yeah.
a process again.
That's correct. Yeah.
All right, yeah, so the question here is, so it happens on each individual shard, or, so the question is, does it happen on each individual shard, and then is there a second round for merging? Just trying
This second round.
Yep. So, and the answer is yeah, there's 2 rounds. The operation happens on each shard, and then the operation, the result of that, all the shards together is then aggregated on the first box that got the initial request.